All right, we're going to continue our study of the conic sections. This is chapter 5, section 2, and we will now study the ellipse. Many people refer to the ellipse as an oval, but here's the formal definition for an ellipse. An ellipse is a set of all points in a plane, the sum of which, the distances from two fixed points, called foci, is a constant. This word here, sum, is going to be really important for us, okay? The sum of which the distances from two fixed points is called a foci is a constant. Here's a picture of an ellipse for us to consider. This ellipse is elongated horizontally. We're going to study ellipses that look like this and also ellipses that are elongated vertically. I'll draw you a picture of a vertical ellipse in just a minute. So there's a lot of things to consider here in this picture. Of course, much more than we had in when we were studying circles. Now look at this. Because this ellipse is elongated horizontally, then the horizontal axis is called the major axis. So this is the major axis. It's the longer of the two axes. The shorter of the two axes, this is the minor axis, okay? The minor axis. Now, the endpoints of the major axis, are the vertices. You have two vertices, right? So this vertex ends the major axis, and this vertex also ends the major axis, okay? And you have a co-vertex and a co-vertex here. The co-vertices are the endpoints of the minor axis. The co-vertices are the endpoints of the minor axis. And then you have these two important points. These are the two fixed points that are mentioned in the definition for an ellipse. Right here where it says two fixed points, that's what these two green points are. Each one is a focus. So plural is foci. Some people call it foci, but I call it foci. So you got a pair of foci here. All right. Now the definition for an ellipse says a set of all points in a plane. So all of these points on the ellipse, on the elliptical curve, all of the points on the curve have something in common, and that is the sum of the distances from the two fixed points is constant. Let me show you an example. So here you can see I identified a random point on our elliptical curve. So this point is on the ellipse. Why? Because this distance from the point to that focus plus, I say plus because in the definition they use the word sum, the distance from this point to the other focus is constant. And it's the same. That sum, this distance plus this distance, is the same for any point that's on this curve. And one of the last things I want to tell you is this point that's right in the middle here is called the center of your ellipse. Okay, so this is the center, and what's really important is that the center of this ellipse, the center of any ellipse, is the midpoint of this major axis. What I'm saying is this segment, this line segment, from this vertex to the center is equal to the distance from the center to the other vertex. So this line segment is equal to this line segment. The same thing for the minor axis. The distance from this co-vertex to the center is the same as the distance from the center to the other co-vertex. Okay, so the center is the midpoint of both axes. Okay, now let's shift our attention to a vertical ellipse, an ellipse that's elongated vertically. Now here's our ellipse that is elongated vertically. A few things about this one. Now you can see how the longer axis is the vertical one. So this is called the major axis. The smaller of the two axes is called the minor axis. Here is the center. The center is the midpoint of the major axis. It's also the midpoint of the minor axis. The endpoints of the major axis holds your vertices. So there's a vertex there and a vertex there. The endpoints of your minor axis are called the co-vertices. There's a pair of those. And then the pair of your foci here. All right. So remember that the definition of an ellipse says the following. If I choose, let's see, I don't know, maybe right here. If I choose a random point on my ellipse, call it point P, has coordinates x and y, then this distance here plus this distance here, like that, that distance plus that distance is constant. So hopefully this is really clear here. This distance, I called it d sub 1, plus d sub 2 is constant. And so it'll be the same for any point that you choose on this curve. Isn't that great? All right, so here's a list of some important things about an ellipse. Number 1, the foci. Those are the two fixed points. They're placed either side by side, right, on the major axis, or up and down, right, depending if it's a horizontal ellipse or a vertical ellipse. The center is the midpoint of the line connecting the two foci. It's also the midpoint of the vertices, like I mentioned, and also of the co-vertices. The major axis is the longer of the two axes. The minor axis is the shorter axis. The vertices are the endpoints of the major axis. Co-vertices are the endpoints of the minor axis. So here we have an ellipse that's centered at the origin, that's elongated horizontally. Okay, so we have, let me call a few things out, okay? The center is at the origin. The vertices are located at negative a comma 0 and positive a comma 0. The co-vertices are 0b and 0 negative b. The foci are located at c comma 0 and negative c comma 0. And I've located a random point on the ellipse. And this point on the ellipse, of course, has coordinates x comma y in the Cartesian plane. And we know that the sum of this distance, d sub 1 plus and d sub 2, is constant. So what we wanted to define or derive really is the standard form for the equation of an ellipse that's centered at the origin. And that standard form equation is x squared over a squared plus y squared over b squared, and it's equal to positive 1. I invite you to look in our online text by Jeff Brower and open to chapter 5, section 2, and they go through a great proof where they are deriving this form for us, this equation for us, so that you don't have to take my word for it. All right? So please look at that when you have a minute. Okay, with the standard form, if A is larger than B, okay, if the bigger denominator is underneath the x, then that means you're going to have a horizontal ellipse. If B is greater than A, that is, the larger denominator is underneath y, that means you're going to have a vertical ellipse. Furthermore, if A is greater than B, that means you have a horizontal ellipse. Then A is the distance to the vertices from the center. B is the distance to the co-vertices from the center. But if B is greater than A, that means you have a vertical ellipse, and B is the distance to the vertices from the center, and A is the distance to the co-vertices from the center. C, if you remember from our diagram that we drew a little while ago, is the distance to the focus, or the foci really, from the center, and can be found by solving this equation. C squared is equal to a squared minus b squared, or c squared is equal to b squared minus a squared. Which one of these do you want to use? You know what? Honestly, use whichever one. Honestly, you're going to use this one when you have a horizontal ellipse. You're going to use this one when you have a vertical ellipse. But just keep this in mind, that C must always be positive. C has to be positive because it's some distance. It's a distance from the center to the focus. Okay, everybody? So just make sure that you never get a negative here for C. All right? Now, we're just about ready to get into our first example, but I do want you to notice that when we were studying transformations in class, we were able to shift a parabola around, or the graph of a function around. The same thing can be applied here to the graph of an ellipse. It can be shifted to the left, shifted to the right, or we call them translations, really, shifted upward or downward. So this equation that we have here on the screen can also be applied to an ellipse that has been shifted to the left or to the right, or up or down. And this is what the equation would look like if the ellipse has been shifted, if the ellipse has been moved in the plane. The main difference here is that instead of just x squared, you have x minus h quantity squared. And instead of just y squared, you have y minus k quantity squared. Hey, notice this, guys. Notice that pretend a squared and b squared were gone. Like, even visually, just cover them up with your hand. Doesn't the numerator look like the equation of a circle? X minus h quantity squared plus y minus k quantity squared. Now, if this denominator, a squared, turns out to be the same thing as the second denominator, b squared, that is to say, a squared is equal to b squared, both of these numbers are the same, then you have a circle. That's a circle. If the denominators are the same, then that's a circle. Okay? And that's why we said in the previous lesson, a circle is just a special case of an ellipse. All right, in example 1, we're going to graph some ellipses by finding the center, vertices, co-vertices, and the foci for every single ellipse. All right, here's the first one. Okay, cool. The first thing I want you to notice in x squared over 16 plus y squared over 25 equal to 1, I want you to notice that the larger denominator is underneath y. So, is it going to be a horizontal ellipse or a vertical ellipse? A vertical ellipse. Very good. Because the larger denominator is underneath y, the major axis is going to be vertical. Now, if you would like, I can rewrite this as x minus 0 quantity squared over 4 squared plus y minus 0 quantity squared over 5 squared is equal to 1. So now I hope that you can see clearly that the center of this ellipse is 0, 0. This ellipse is centered at the origin. Your a value is 4 and your b value is 5. Okay, guys, so this is what we know. Vertical ellipse, center at the origin, a is 4, b is 5, c is unknown. We don't know c. And we need to know c in order to find the foci. All right, so do you remember how we're going to find c? C is equal to, or c squared, excuse me, is equal to, and remember we want to be positive, so I'm going to write this as b squared minus a squared, like that. That is to say, c squared is equal to 5 squared minus 4 squared. So then c squared is equal to 25 minus 16. C squared is equal to 9. And that means that c is the number whose square gives you 9, which is 3. We do not want to say plus or minus 3. We just want to say positive 3 because c is a positive distance, okay? Okay, everybody, I'm going to move the screen, but I want us to take this information with us. The center's at the origin. A, which represents the distance from the center to the co-vertices. And B, take this with you, it's the distance from the center to the vertices. And C, now we just found it, is 3, is the distance from the center to the foci. Let's graph this. Okay, guys, the first thing I like to do is to plot my center. So I'm going to say my center is here at the origin, okay? And I want to plot my vertices. Now, my vertices can be found by moving 5 units up and 5 units down from the origin. Remember, 5 units because that was the value of B, all right? So when I go up 5 units, I end up here at positive 5, If I go down 5 units, I end up here at negative 5. And then I want to move to the left and to the right 4 units. 4 is the value of A. When I move to the right 4 units, I end up there. And to the left 4 units, I end up there. Okay? And I also want to plot my foci. Now my foci can be found by moving 3 units to up and down, up and down 3 units from the origin. So from the center, so up 3 units would be here, and then down 3 units would be right here. Okay, so now I'm going to draw the curve through my vertices. Okay, so here's my ellipse. Okay, so this is what we have. We have our center, we have our co-vertices here, we have our vertices up and down here, and your foci. Okay, let's label all of our work. All right, here's the summary, guys. So got our center, we got the ordered pairs for our vertices, we have the co-vertices as ordered pairs, and the foci. All right, I also want to draw this attention to you, or for you. The major axis is here, it's vertical, and the minor axis is here, it is horizontal. Here's our new ellipse, everybody. X plus 2 quantity squared over 9 plus y minus 1 quantity squared over 4 is equal to 1. Okay, watch this. Who has the larger denominator now? This one has the larger denominator. It's underneath x, right? So the x term has the larger denominator, so therefore this ellipse will be horizontal. So this is what we know so far. The ellipse is horizontal. When I say the ellipse is horizontal, I mean the major axis is horizontal. The minor axis will be vertical. The center is at -2, +1. Be careful with your signs, right? Standard form says x minus h. So then you take the opposite of what you see, very similar to what we've been doing all along. Like when we study other things, like we did that with the parabola and with the circle. And then a +1. Okay, so -2, 1 is our center. That's in quadrant number 2. Your A value is the number whose square gives you 9, so A is 3. Your B value is the number whose square gives you 4, which is 2. Okay, guys, what we do not know is C, and C is going to help us find our foci. So I'm going to set up my equation. I want a positive number for C, so I don't think I want to do b squared minus a squared, because that would be 4 minus 9, which would be negative, right? So I want to go a squared minus b squared. That would give us 9 minus 4, which is 5. Be careful, that's not c, that's c squared. So then c, after taking the square root of both sides, is equal to the square root of 5. Now, I want to figure out the ordered pairs for my foci. So how am I going to figure that out? Well, allow me to draw a quick little sketch. I'll do a much better graph in just a minute, all right? But just bear with me just for a second. So our ellipse is horizontal, right? And if this is my center right here, my foci, remember, my foci will lie on the major axis here. So if this is my major axis, like that, right? My major axis is horizontal, then my foci lie on this major axis. In other words, the way you're going to find your foci is by starting at your center and moving to the right, C number of units. Starting at your center, moving to the left, C number of units. In other words, you're going to start at this center here, -2, 1, which is here, right? -2, 1, and then move to the left, root 5, and then move to the right, root 5. Now keep in mind, when we say move to the right, that means we're adding root 5 to -2. When you move to the left, that means we're subtracting root 5 from -2. So the ordered pairs for your foci are It'll be negative 2 plus root 5, comma 1. And then it'll be negative 2 minus root 5, comma 1. All right, cool. Now let's get the graph. All right, a much better graph than this little sketch that I was doing here. Okay, you guys, I have a graph going here. So I know my center is negative 2, positive 1. And I want to move to my vertices. Now this ellipse is horizontal. So I'm going to move to the left and to the right a number of units, which is 3 units, right? So I want to move to the left 3. That puts me at negative 5, 1, over there. And then, so that's a vertex. And then move to the right 3 units. That puts me at 1, 1. That's the other vertex, okay? When I move up and down from my from my center, I get my co-vertices. Now, from the center, I'm going to move up and down b number of units. That is 2 units. All right, b is 2. That puts me there at negative 2, comma 3. And then down 2 units puts me at negative 2, negative 1. Okay, so I'm going to go ahead and draw my ellipse in now. All right, something like this. All right, not too bad, okay? Draw my major axis for you guys, right through my center, like that, okay? And then my foci are, I'm going to label them now. One of them is negative 2 plus root 5. And we know we know root 5 is a little bit more than 2. So then negative 2 minus root 5 will be to the left of negative 4, right? A little smaller than negative 4. So maybe over here somewhere, all right? That's a foci. That's a focus. And the other one is going to be negative 2 plus root 5. So remember, root 5 is a little bit more than 2. So then this value is going to be really close to 0, but positive. And the next focus is about right there. That's the other focus. Okay? So I just wanted to make sure I had this information labeled really nicely for you. The vertices are negative 5, 1, and 1, 1. The co-vertices are negative 2, 3, and negative 2, negative 1. That's these red plotted points here. I already wrote down the foci up here, the ordered pairs. And earlier on the screen, I wrote down the center for you as negative 2, positive 1. All right, cool deal. We did it. All right, example 1, part C. 9 times x minus 1 quantity squared plus 5y squared is equal to 45. Okay, first things first. This needs to be a 1, and it's 45. The only thing that'll make this a 1 is if we divide it by itself. 45 divided by 45 is 1. So I'm dividing every term by 45, and then I get x minus 1 quantity squared is equal to, over 5 plus y squared over 5 goes into 45 9 times is equal to 1. Now this is in standard form. Hey, don't forget that that second term can be rewritten if you wanted to as y minus 0 quantity squared over 9. Okay? Okay, so because the larger denominator is underneath y, we know that this will be a vertical ellipse, meaning the major axis will be vertical. The center will be positive 1, comma 0, 1, 0. All right, so I'm just getting my information down. The major axis is vertical. The center is 1, comma 0. Now, what about a? Now, don't forget, this is not a. 5 is not a. 5 is a squared. So if 5 is a squared, that means a is the square root of 5. Allow me to elaborate a little bit on that. I know that this number down here needs to be a squared. This number needs to be what I get when I take a and I square it. So if a is root 5, what do you get when you take root 5 and you square it? When you square this number, it just gets rid of the square root and you're left with 5, which is that number. So this is what a is, all right? The square root of 5. B is going to be the square root of 9, but that's just 3. All right, very good, you guys. What's missing is c, so we need to find c. Now, c squared is equal to, remember you want it positive, so start with the larger number. It'll be b squared minus a squared. Don't forget, guys, that this number right there is b squared, and that's a squared, all right? So then that means it's going to be 9 minus 5, which is equal to 4. Also, don't forget, please, that 4 is not c. 4 is c squared. So let's take the square root of both sides, and you're going to get c is equal to 2. All right, just to make sure I don't lose anybody, I'm going to draw you a quick little picture. This is not my final graph, okay? This is just something I want you to consider. If this is my ellipse, and it's vertical, and there's my center, then my foci, there's one focus, and the other focus is like right there, right? The way I get my focus is by starting at my center and then moving up and down c number of units. So starting at, what is your center? Your center is 1, 0. Starting at 1, 0 and going up 2 units. That's what c is. Go up 2 units and then go down 2 units from your center. All right, look what I did for you guys. Your center is 1, 0, right? So when you move up and down from your center, you're changing your y coordinate. So here it is, 1, 0 plus 2, and then 1, 0 minus 2. That's 1, 0 plus c, 1, 0 minus c. To give you your foci of 1, 2, and 1, negative 2. Those are the coordinates for your foci. Okay, what do we have? We have, we know what our major axis is, we know what our center is, and we know what our foci are. Let's graph the ellipse, and then we'll identify clearly the vertices and the co-vertices. All right, you guys, I have my center plotted, and remember this is going to be a vertical ellipse, so I'm going to move up and down from the center and find my vertices. I'm going to move up and down b number of units. Do you remember what b is equal to? B is equal to 3. So I'm going to move up and down 3 units from my center. So when I move up 3 units, I end up at 1, 3. There's one vertex right there. Then I'm going to move down 3 units, and that leads me to 1, negative 3. There's my other vertex, okay? Then I'm going to move to the left and to the right a number of units. Now, a is the square root of 5. The square root of 5, you can punch that into your calculator. It's going to be a number that's a little bit bigger than 2. Just a little bit bigger than 2. So when I move square root of 5 units to the right, I end up right here a little bit greater than 3. When I go square root of 5 units to the left, I end up with something that's a little bit less than negative 1, give or take. All right, everybody? And then my foci, these red dots here that I plotted, points, the red points, are your co-vertices. For your foci, remember they're going to be located at 1, 2. So 1, 2 is about right there. That's a focus. And the other one is 1, negative 2. So that's the other focus. All right? Cool. Let's do our best to draw the ellipse. Okay? Okay. There's my ugly ellipse, okay? All right, cool. This here is your actually I was going to point at it. Let me actually draw it in here. This is your major axis, what I just drew. Okay, guys, I have it clearly labeled here. The vertices are 1, 3 and 1, negative 3, and my co-vertices are 1 plus root 5, 0, 1 minus root 5, 0. All right, I hope you are getting this. Okay, guys, 2x squared plus 3y squared minus 8x plus 6y minus 1 is equal to 0. What I hope you find obvious here is that this equation is not in standard form for an ellipse. So I'm going to use a strategy here that we did with our circles. I want us to complete the square in x and complete the square in y. To get that started, I'm going to group my x terms together, and I will group my y terms together. At the same time, I'm going to add that 1 to the right side. I am going to complete the square in x, but before I do that, this leading coefficient right here has to be a 1. So what I'm going to do is I'm going to factor a 2 out from both terms. See now, my leading coefficient now is 1, and now I can complete the square for x. In order to get my leading coefficient to be 1 over here, I'm going to have to factor out a 3. All right, like that. Okay, so now I'm going to complete the square. I'm going to remind you that you complete the square by taking -4, that's the coefficient of the first degree term, and take half of that, okay, which is -2, and then you take -2 and you square it, and that's going to give you a 4. You are going to add a 4 right there after the -4x. You're going to squeeze it in right there. Over here, you're taking half of 2, the coefficient of the first degree term, and you're dividing by 2, which is 1, and then you're taking 1 and you're squaring it, which gives you 1. So you're going to add a 1 right there after the 2y. Okay, so then that gives you, make sure you have that down because I'm going to erase it so that I can work right underneath that green area there. So that's going to give me 2 times x squared minus 4x plus 4 plus 3 times y squared plus 2y plus 1 is equal to 1 plus, now, you have to be very careful, just like you did with circles. Whatever you add to the left-hand side of the equation, you must add to the right. But be careful. I know you wrote 4 right here, but really, you see that 2 that's out front? It's 2 times 4. That's 8. And this is 3 times 1, which is 3. So really what you need to add to the right-hand side is an 8 and a 3. Man, that's tricky. So you have to be careful there. So what is this? 2 times x minus 2 quantity squared plus 3 times y plus 1 quantity squared. I did talk to you in the previous lesson on how to factor these perfect square trinomials, okay, is equal to 12, okay? Now, this is still not in standard form, but it's really close. All we need now is this number to be a 1. Now we got our perfect squares, our a perfect square in x and in y, and then we just need this to be a 1. In order to get that to be a 1, all you really need to do is divide everybody by 12, right? Because 12 divided by 12 is 1 over there on the right side. So then your standard form is x minus 2 quantity squared over, now 2 goes into 12 6 times. I just did this right here, folks. I just want to make sure I'm very clear. 2 divides into 12 6 times. That's what I'm doing. And then 3 is going to divide into 12 4 times. All right? So I'm going to have y plus 1 quantity squared over 4 is equal to 1. This is standard form for the equation of our ellipse. Cool. What kind of ellipse do we have here? Well, let's consider. The larger denominator is underneath x. That means we'll have a horizontal ellipse, meaning the major axis will be horizontal. All right, I have the major axis is horizontal, and then the center is +2, -1. I can't stress enough to make sure your center is correct. Watch out for your signs. Okay, let's identify A and B. Remember that this number represents A squared. This is A squared. That must mean A is just the square root of 6. Okay. So that's what A is. And then B is the square root of 4, which is just 2. All right, cool. What we don't know is c. So let's use this. C squared is equal to, and let's do a squared minus b squared so that we end up with something positive for c. So then this is 6 minus 4. That's what c squared is. So c squared is equal to 2, which means c is equal to the square root of 2. All right, cool deal, everybody. Let's identify our foci. All right, because my ellipse is horizontal, what I'm going to do to find my foci is start at my center and then move left and right, which of course means that we're adding and then subtracting a c number of units, which is the square root of 2. So we're going to add root 2, so 2 plus root 2, negative 1. And then the other foci is 2 minus root 2, comma, negative 1. You know where I'm getting the negative 1 from, right? It's right here. That's the second coordinate of my center. All right, cool. Those are the coordinates for my foci. Let's graph this ellipse, and then we'll identify our vertices and our co-vertices. Okay, everybody, I have my axes here. I have my center plotted. Now to get my vertices, I'm going to move to the left and to the right because it's a horizontal ellipse. I'm going to move to the left and to the right a number of units. Now a is equal to the square root of 6. The square root of 6 is a number between 2 and 3. Okay, so let me move to the right a little bit more than 2 units. So maybe about right there. That'll be one vertex. And then when I move a little bit more than 2 units to the left, I end up about right there, okay? All right, cool. So those are my vertices. Now when I move up and down b number of units, which is 2 units, then I get my co-vertices. So I'm going to move up 2 units from my center, which puts me at 2, 1. That's a vertex. And when I move down 2 units from my center, I get the other co-vertex. My foci, I already labeled them. My foci, one of them is 2 plus root 2, comma, negative 1. So basically move to the right c number of units, which is root 2. Root 2 is a little bit more than 1, just a little bit more than 1. So my first focus is maybe about right there. That's a focus. And when I move to the left a little bit more than 1 unit, that's 2 minus root 2. It's going to be about right there. Okay, that's my other focus. Cool. Now, whoa, almost missed that vertex right there. All right, so there's my ellipse, and my major axis goes right through my focus. And of course, it may not look like it, but this center is the midpoint of my major axis. All right, let's clearly label the coordinates for my vertices and my co-vertices. Now remember, guys, this is a horizontal ellipse. So then my vertices actually are found by starting at my center, 2, negative 1, and moving to the left and to the right, root 6, right? Number of units. So then it is 2 plus root 6, comma, negative 1. And then the other vertex is 2 minus root 6, comma, negative 1. My co-vertices were found by starting at my center, which is 2, negative 1, and moving up 2 units, which is 2, 1, and moving down 2 units, which is 2, negative 3. All right, cool deal. All right, guys, we're definitely on our way. Let's keep studying. All right, you guys, I love these kind of questions. Find the equation in standard form of the ellipse with vertices at 0, positive 5, and 0, negative 5, and foci at 0, 3, and 0, negative 3. All right, I like to start these questions by writing out the standard form for an ellipse. What is it? X minus h quantity squared over a squared plus y minus k quantity squared over b squared is all equal to 1. This is what they're looking for from us. Now, Look at what they gave us. They gave us the vertices. Do you notice that your vertices lie on your y-axis? 0, 5, and 0, -5. Those are points that are right on the y-axis. That means your ellipse is vertical. Your major axis is vertical. That means the larger denominator belongs underneath the y term. All right? So here's a visual just in case it helps anybody. I think it's really a good idea for the next couple of examples to sketch just a rough sketch of what they've given you. They've given you your two vertices, which are right on the y-axis, and your two foci. And remember, because the ellipse is vertical, your b value, I know this is b squared, but your b value tells you the distance from your center, which I think we can figure out that your center, since it's the midpoint between your vertices, has to be at the origin. That's your center, right? So this distance here from the center to your vertex, the distance from your center to your vertex is b. So I hope that you can see that your b value has to be 5. B has to be 5. That's the distance from your center to each one of your vertices, right? Now, what about your C value? What about C? C tells you your distance from the center to your focus, to each one of your foci. But we can see now that that distance is just 3 units. So then C is 3. So I think what's clear here, hopefully, excuse me, what's clear here is that A is missing. Right, everybody? A is missing. So then let's use that formula that says C squared is equal to, should I write it as A squared minus B squared or B squared minus A squared? Well, this is a vertical ellipse, which means B squared is going to be bigger, so let's start with that number, okay? So then B squared minus A squared. Now we know C is 3, so this is 3 squared. We know B is 5, so this is 5 squared minus A squared. Solve this for A. All right, so you're going to get A squared is equal to 25 minus 9. I added A squared to both sides, and I subtracted 3 squared from both sides. And I also wrote 5 squared as 25, and 3 squared as 9. So then A squared is equal to 16, which must mean that A is 4. Cool. And you know what I just realized here is that we really don't need A, because that's, look at the standard form, it just calls for A squared. So I could have stopped once I got A squared. So I don't need to go all the way. I don't need to take the square root of both sides. All right, do we have everything we need? What do we need in order for us to write it in standard form? We need the vertex, we need the center, h comma k, the center, and we need to know what A squared and B squared are. We know what B squared is. B squared is going to be 5 squared, which is 25. We just figured out what A squared is. And now because I drew a little tiny sketch, we can see that the center is 0, 0. Cool. So let's write down our standard form. Our standard form will be x minus 0 quantity squared over A squared, which is 16, plus y minus 0 quantity squared over B squared, which is 25, is equal to 1. Let's simplify this as x squared over 16 plus y squared over 25 is equal to 1. This is the standard form for that ellipse that they were describing. That was fun. Let's do another. Okay, guys, this is the last example in the section. Find the equation in standard form of the ellipse with minor axis of length 4 and vertices at -7, 1, and 1, 1. Okay, now guys, let's draw a quick sketch. And I really mean it when I say a quick sketch of our ellipse, okay? So something like, thinking about the vertices there. Okay, so what about this? 1, comma 1, and -7, comma 1. See, I'm telling you, I'm not being super picky about my graph. So 1, 1, and -7, 1. Those are my vertices, okay? And then it says the minor axis has length 4. So then the ellipse is like something like this, right? I know it's horizontal because they gave me these vertices that are to the left and right of each other, right? And so the vertices are the endpoints of the major axis. So the major axis is horizontal. Okay, you guys, do you remember where the center is? The center happens to be the midpoint, of your vertices. Do you remember that midpoint formula? The midpoint formula is like this. So the center is the midpoint between your vertices. So then the center is found by using the midpoint formula. It's adding up your x coordinates. So -7 plus 1, dividing it by 2. And then adding up your y coordinates and dividing those by 2. You guys, these coordinates were given to you. They're right here. So it's -7 plus 1, and then it's 1 plus 1, and then you're dividing by 2. This is the midpoint formula. We've used it before, right? So then your center is -3, comma 1. This is your center. I'm going to go ahead and plot it for us right there. So -3, comma 1. Now this is really good because this distance here, you guys, this distance here, what color should I use? Let's use green. The distance from your center to your vertex, that's what A is. So then can you figure out what A is then? A has to be 4 units. That's right. So A has to be 4. That's the distance there. And then what about B? Well, B is the distance from your center to your covertices. But they told you that the minor axis has length 4. The minor axis goes right through your center, and the endpoints of your minor axis are your covertices, right, everybody? And they're telling you now. Don't lose fact. Don't lose don't lose the fact that the minor axis here goes right through your center, and they've already told you that the minor axis, the whole thing, is 4 units, right? And because the center is the midpoint of the minor axis as well, that tells you that this much is 2 units and that much is 2 units, right? If the center is the midpoint of the whole minor axis, that means you got 2 units up here and 2 units down there, right? So B, going back to B is the distance from your center to your covertices. So then B must be 2. Did you follow that? Okay. Okay.